We now write the rules of the following differentiations. So in part A, we have to differentiate a constant, that is dc by dx. Differentiation of any constant is 0. So we put 0 for this one. Now let's do the part B. And here we have to differentiate u of x raised to the power of n. So basically first we have to apply the power rule, and when we do that we put n in front, and then u of x raised to the power of n minus 1, and then we multiply with the differentiation of the u of x. So we write differentiation of u of x. So the next step, we can rewrite this as the first, this becomes n times of u of x raised to the power of n minus 1. In fact, we rewrite this as simply as d by dx of, or d of u of x over dx. Now let's do the part C, that is differentiation of u plus v. So this is basically a sum rule. So this equals, we have to differentiate each terms one by one. That is d by dx of u plus d by dx of v. We can rewrite this d by dx of u as du by dx, which is the differentiation of u with respect to x. And we can rewrite this as dv by dx, which is the differentiation of v with respect to x. Now let's do part D. That is, this is basically a product rule. So first, we can consider this as a first function and the v as the second function. So here we differentiate the first function, that is d by dx of u, and then multiply with the second function, that is product of v, plus then we consider the first function and then multiply with the differentiation of the second function, that is d by dx of v. We write this in simplified form as d by dx of u can be written as du over dx, which is the differentiation of u with respect to x, multiply with v, plus u times of dv by dx, which is the differentiation of v with respect to x. So it's basically du by dx times v plus u times of dv by dx. Now let's do part E. That is, this is basically a quotient rule. So first we take the quotient, that is v, and multiply with the differentiation of u. And then we subtract. Now we take u and then multiply with the differentiation of v. That is d by dx of v all over v square. Let's write down this in simplified form. So this equals v times of du over dx minus u times of dv over dx over v squared. So the differentiation of u over v is v times of du over dx minus u times of dv over dx all over v squared. Now let's do part F. So here we have to differentiate the exponential function. So basically differentiation of exponential function will be the exponential function, that is e raised to the power of x. And then when we apply the chain rule, we have to differentiate u of x. So we write down this as differentiation of u of x. Now we can write this in simplified form, that is d of u of x over dx. We then have this e power ux. So it's basically e power ux times of d of u of x by d of x, which is the derivative of u of x with respect to x. Now let's do part G. This is a differentiation of a logarithmic function. So this basically equals, if you differentiate the logarithmic function, that is a natural logarithm function, we get 1 by u, and then we apply the chain rule to differentiate the u. That is, we put d by dx of the u. So this can be written as du by dx. So therefore, this becomes 1 by u times of du over dx. And du over dx is the derivative of u with respect to x.